Welcome to this April's meetup. Today, because one speaker is ill, there will be a slight change of plans. So basically, we will have a panel discussion after the first talk, and it will be about open source. And we will try to compare view from programmer and view from a company. So how programmer can step into open source world and how community can step in. But first, we have the first talk about Elm, and it's from Marko Gershak, who is a lead front-end developer in Pamoja tribe at DLabs. Zealous about sharing his deep and wide JavaScript knowledge, and you shouldn't be surprised to see him contributing all over the web. So let's give him a warm welcome, and let's start with Elm.
Hi, as Nate introduced me, I'm Marko. You can find my contacts at gresak.io or at my handle at Marko Gresak on GitHub, Twitter, and so on. So a bit about me. I'm senior front-end developer at DLabs, and my credentials about Elm are more of example, and my personal apps. I'm not working on Elm professionally, but I also have a final thesis on comparing Elm as a language to developing web apps in React. So first about Elm, who here has heard about Elm and work with it? Oh, okay. So I hope you are forgiving. This is the quote from the webpage. The Elm is a delightful language for reliable web apps. And I took that as a challenge to prove if this is true by developing an example app in first React and then Elm and seeing how this proves in real world. They also claim no runtime exceptions, which is a huge claim, especially in JavaScript world where everything is an exception as long as you look a bit, I don't know, if you're tired or something and everything breaks. It's a domain-specific functional language which is also statically and strongly typed. The domain-specific part is because Elm is only targeting web apps, so you can't take it and run it as a, I don't know, app server or something like that. There are attempts to run it on Node, but there's nothing official and nothing that works for production use. So about functional languages, the main two things about Elm is the singular data flow, like for example in Flux or Redux, and everything is immutable. So once you set some value, there's no way of changing it. You have to return something else or define a different value which is updated. So this ensures that you don't change the state accidentally. You have to explicitly do every change in the app. About types, Elm supports type inference, so you don't have to define every type. The compiler will help you with that. So if, like, the compiler is developed in Haskell, so every idea from Haskell's type inference is also applied in Elm. So the compiler will know what types you're using, so you don't have to go and type it in, but it's suggested so to make sure the code is easier to read. For example, just a basic type with options which has possible values of option 1, option 2, or option 3. This is like something like a tuple or enum in C. If a developer chooses to get the case of option and only handle option 1, the compiler will say you're not handling options 2 and 3, and this will be a compiler error. So something like this will not pass the build. So as the compiler suggests, you have to add either options 1 and 2 and handle some extra case, or the wildcarders. Here's the underscore is just a, by convention, the value which you are not using, but this is an arbitrary variable name. So if you were to use A and say, I don't know, something with A that handles type option, you can do that as well. The Elm architecture is the main part of how Elm is solving the problem of data flow and interactions in the web apps. And it also influenced the Redux and Vuex, which is a state handling library in Vue. The main three parts are model, update, and view. The model is just a type which defines how the data is stored. It's an arbitrary type. You can nest types. For example, there is login data, which is of login model type. So there is another set of fields dedicated to that. Others are mostly from the library. So root is from the routing library. Web data is from API helper library. Maybe is a monad. I won't go into that. And the session is just my custom type to handle session data for the user. The update is a function which, as the type definition here suggests, takes some kind of message, the current model, and returns a new a tuple of new model and next comment with message. In this case, there are three cases for message. The navigate to, which is triggered by the router library, sends a new navigation.new URL. It's a custom function to handle routing, which is then intercepted here to update the root value in the model. This pipe operator is object concatenation, so takes the value of model and changes the root value. Everything else stays the same, but because of the immutability, this is a now new object. And on fetch posts is my custom action, which gets a response value from the API and sets the post to this response value, which is then handled later as web data, which may contain a list of posts, or also encapsulates info about API errors and so on, but this is handled in the view part. For the view, I won't go deep, but mainly the idea is it's a function to get a value for current model and display some data to the user. These are all functions, so div is a function which gets an array of props, an array of children, similarly to how React is working if you don't use the JSX syntax. But these functions are then internally mapped to virtual DOM and then displayed to the DOM, and Elm is working on making this as performant as possible. If you look on their web page, the rewritten Vue library is extremely fast, faster than most of the alternatives. Then using existing JavaScript APIs, because Elm is a new language, you can't just go on npm, pull something, I don't know, moment.js and use it. You have to use some kind of interface, which is done by port keyword in Elm, which is just a function without a body. It accepts, so this first one is like an out function, so something you send to the JavaScript, and the in function is something you get from the JavaScript. The A is kind of arbitrary type, but not really. It just supports these values. So basic primitive values, int, float, bool, string, maybe then lists, arrays, tuples, JSON values, and record, which is the object type like I showed earlier. So the specifics here are out function gets some kind of typed value and returns a message, which is then handled when in the update function. So you know that something was sent, but this is everything here is asynchronous. So the in function then accepts a sub, which is type for subscriptions, and handles this again through some special helper and sends it to update function. So you can't do synchronous actions here, and this is every JavaScript API interfacing. So even date.now, it's asynchronous, which is kind of a pain sometimes. And in JavaScript, the first line is just LM initialization. So LM knows to use full screen, so renders the whole app in the body. The instance app.ports then has every function. So out fun from before is name mapped from the LM to JavaScript, and everything is name by name. So if I were to use some other name, this name would be here. And out function has a subscribe method. So every value I send from LM is triggered here, handled asynchronously through the callback, which accepts a data. So because there is only one argument, the data is only one value, and this can be either a primitive value or a object. And the programmer needs to handle that and also know that there could be errors here. So this part is where the no runtime exceptions promise fails, because this is not LM anymore. And the sending value into LM is just via send function. This is synchronous, but just in JavaScript, because in LM it's again asynchronous because of how the library is handling these calls. And another strange thing in LM is how the JSON is handled, because in JavaScript we know that you can just parse JSON and it will hopefully work if the JSON is valid. In LM we need a special type for the JSON and decoder, so every value that we want needs to be decoded. This syntax here is is provided by a special library for decoding, which is a part of not LM standard pack, but it's developed by the official so the core developers. So it's very well maintained, very well documented. Everything is up to date, so it won't just break. Here, the required fields are something that we expect to always exist. So if the JSON is provided, for example, without the ID field, this will fail, but it will be a failure as part of the decoder something error. So again, the developer needs to handle this flow in their app. And the optional value is something that doesn't need to be present, and we decode it as int if it's present, but for example there is a null, so it will just default to the 0. And something that I thought was interesting about LM when I first started reading about it is LM CSS, which is type safe CSS on the kind of like component styling in React. This also handles scoping of the CSS, so you don't have to think of a name for every class and use something like BAM or I don't know, some naming convention, so you don't overwrite your styling rules. And every property here, so for example display, padding, border, and so on, is a function, and then inline block is type from the library, and it knows, so you can say display and I don't know, solid black. It will fail at the compile times and provide a meaningful warning message of what went wrong, so you can easily fix it. Developer tools. Our first LM make, which is the official compiler, takes LM files and outputs it as JavaScript or HTML with JavaScript in it. LM package is a custom package manager which respects SAM versioning because of the types. The promise is to never ship a minor update with a major change or something that breaks API, and because of the type safety, this can be ensured, unlike NPM. Elm REPL is just a quick way to test some Elm code, because it's a functional language, this might be difficult to try out some complex code, so it might be easier to just make a quick example app. Elm Reactor is a bundled make plus web server, so it will automatically build and reload the page to show new code. So you don't need development setup and everything to test some code. You can just run Reactor and go. The formatter is not part of the official 4 tools, but it's very commonly used to provide formatting rules. Also works kind of like linters, so you can check if there are some inconsistencies, and for example in the build part of your CI or something like that. And there's also Prettier plugin as a work in progress, so just Prettier running Elm format and going with that. And about the demo app I mentioned earlier, I was comparing Elm with React as kind of like a Reddit clone app. The main features were just to test some more complex rendering. So here is a nested rendering of the same component. So this every part is the same comments component, handling user login, registering, API requests, adding new content, editing, deleting, just the basic CRUD app stuff, just to show the basic feature set that every app is using. And this is deployed, the backend is on Heroku, developed in Elixir, and the frontend is deployed via S3 and CloudFront just for better performance. So a quick demo, because I'm running out of time. There's nothing much to it. There are posts inspired by Reddit. So this one is Elm. Everything of the styling is done by Elm CSS. The API is a bit slow. That's not Elm being slow. So I guess Heroku doesn't like me today. So for example, this is like the real performance when the Heroku wakes up. The idea is to render comments deeply nested to allow collapsing and expanding sections, upvoting, downvoting. And the React one is similar because they use same styling, same DOM positions, no positions, but DOM structures. So everything is the same position. The only thing that is slower is in React. So this one is React now. Logout takes loading and then shows. In Elm everything is instant. Just logs out, updates the state to not logged in user. So there are no upvotes, and the buttons to add content are hidden now. The source code for this, also first comparison, okay. I used Lighthouse from the Chrome developer tools, just the performance metrics. So Elm was slightly faster, mostly because the file size is vastly lower. This also impacts the performance ratings that Lighthouse gives and the perceptual speed index, where the lower value is better. This is somewhat correlated to the time it takes to load. Mostly the smaller build size is because Elm is really packed with everything you need, and in React I needed to add all kinds of library to handle dates. I used Moment for I don't know, styling and so on. There is just picking little things that where you don't need most of the stuff, and they just bulk up and add to that. And I could optimize that, but I didn't with intent to show how much the React just bloats your project and how Elm is ships with everything you need, but strips it in the production build so you don't ship too much. Source code is on GitHub. Both projects depend on backend, or they can use Heroku. The link is in the Heroku link is in the backend. About the developer experience, no runtime exception. As I said, when you come to using JavaScript, you're on your own. But when I was working with Elm, there was no unexpected errors. There's few bugs that I messed up, but because of the compiler, I could quickly find the issue. And most of the code that compiles is also bug-free because you think about what you're doing. So this is also type safety. If it's a friend or foe, it depends on how much time you have. If you have to quickly develop a prototype, the type safety will really eat up on your ass because it slows you down. You have to really do it properly, or it won't work at all. It won't even compile. But it allows robust apps which take more time to develop, but you really can maintain them because you have to think more about what you're doing. You can't just put some code in, hack something together, and say you will handle it later, which is never. But alternatives, because if you are working on tight deadlines and you're limited by the development costs, which are real-life constraints, and don't want to introduce lesser-known technology like Elm, which doesn't have the mainstream appeal, you can use something like TypeScript and React, which has a easier point of entry. Everyone here hopefully knows JavaScript, hopefully is familiar with React just a little bit, but it's also easier to learn. And you can use React Elm components to gradually add Elm. So you have few components which are done in Elm, but everything else is in React. And a pro tip, lifts command line tool, React JavaScript to TypeScript transform takes React JavaScript components and kind of compiles them to TypeScript with correct types based on prop types, tries to do it like port, so it should work in TypeScript out of the box. I haven't tried it in production, but for smaller apps, so for example, the one that I was working in from the demo app worked well. And moving forward, how to use Elm at work is a blog post by the original author who talks about the library that I mentioned earlier to gradually add Elm via React components. And then Elm documentation and an introduction to Elm, which is the official book. Those two are really good resources, and also the documentations of the library are really well written, at least for the official APIs. And now someone wants to ask something.
Okay, thank you very much. First question.
Does Elm have any kind of like component with mount, component with mine kind of
Life cycles.
life cycle?
When I was trying to handle this, there was no like, you probably mean from React, where you have the stateful components. I didn't find anything completely like that, so you kind of have to hack it yourself.
So how do you know when components will receive data or if something updates?
You have more straightforward data flow from the functions, so the update function knows when you're updating something, so immediately after that the re-render happens, so you can rely on that.
Probably you're more moving from components to the state, right? For
Yeah.
handling changes.
Yeah, everything is in the state. So the one thing that I was running into, because of my experience with React, where you have internal state and you sometimes use it to handle. One example is the where I showed the toggling of the comment. So in React, I did this in the internal state, so it's fairly easy. You just set state and render accordingly. In Elm, you don't have that. You have one big state and everything is inside there. So every update for the little component needs to go to the whole state update, update the particular part, and re-render everything where the rendering library knows what it has to render, so just not a repaint of everything. But I had to find that one ID, match it, update it. This was a bit of a pain to figure out. You don't have other state, you have just one complete state and that's it.
So it's more or less structured like a tree, or something like that. Can you structure it?
Yes, it's basically when you, so back here, in the model, this is, in JavaScript, this would be a basic object, and login data here is kind of a subtree of the state. So this is the type, but accepts only these values. If you look into the state debugging tool, this is so sub-objects or subtree of that. And another thing, when I mentioned the debugging tool, and I heard you talking about the repeating of the state earlier. Elm has this built-in in the development builds, so you get trace of all actions that happened. You can export this as JSON, import it on your local machine, and repeat all actions. So you can reproduce the exact state that someone from the, for example, from the QA found on the staging and see what went wrong.
Any more questions?
Yeah. How, well, this example has what, 100 posts. How does this shared state work in an example where you would have like 10,000? Because that was the problem with the original Angular, the Angular 1, that basically it worked perfectly on 100 of shared state, but as soon as you draw that to 10,000, the app grinded to a halt.
Original Angular has two problems. First one is the limit on subscriptions. So here it depends on what you're doing with these components. If you're just rendering, it doesn't matter. But here, because there are some actions, especially for the comments, where I can, okay, I can't now, but when logged in, there are actions to reply and so on. Each one would register a subscription. This is the first problem in Angular, and this is done differently here. Second one is just how much DOM elements you render, and this is, everything has problem with that. Plain HTML would have problem with that at some point. You can't really solve that. You have to do it in a different way. I don't know, render it incrementally or render just what you see or something, but nothing will help you there because this is limitations of the browser and performance. But as far as Elm goes, the rendering engine is using the smart updates. So if you know, like in React or the new Angular, it won't render the whole app or the whole components like Angular is doing, the original Angular. It will try to find, so if I change something here, it will re-render just this one part, not everything else. So these are few smaller solutions to help you get, I don't know, from 100 posts to 200 or 300, but not to tens of thousands, because you can't solve performance like that.
Thank you for your nice talk. I'm wondering if would you suggest Elm for the learning language for principle of functional programming?
If you don't know anything about functional programming or really just the basics, it's a nice way to start because you're still building something visual in comparison to other languages which are more of the I don't know, build a command line tool or something like that. And especially Haskell is one of the first to go to, or Scala, and there are a lot of abstractions to get to know there. I don't know, Haskell has too many ways to handle a string in all the possible cases. Elm is trying to strip that down to really the basics. Doesn't allow many abstractions, therefore it's more verbose sometimes, but it's really, to learn it and to understand it, it's a great language to really know what's going on and don't go shuffling through the documentations and trying to figure out what is what and why something doesn't work. And another thing, this compiler errors, this is not just a cherry-picked example. These are all over the place. If you Google it about the suggestions there, I even found a post where someone found themselves, someone with ADHD found themselves more productive because of these kind of messages. So they knew what happened and didn't lose focus because some vague error. So another point of why Elm tries to provide nice development experience and would probably be a great learning language for functional programming. But then, as I mentioned, more abstractions like in Haskell would probably need to be another step if you really want a fine grasp on functional programming.
One more.
Any experience with server rendering with Elm?
Elm doesn't support server rendering unless you do some kind of hacking to emulate a server like this, the Chrome or Puppeteer or something like that, render it in there and return HTML, but doesn't work on server officially, doesn't support any official server-side rendering. Even the WebAssembly support is just a nice idea but doesn't work, so it's mostly web app, not even mobile apps like React Native. You could wrap it in some kind of web view, but that's it. So mostly targeted at web apps, desktop, mobile, in the browsers, and that's it. So, but there are some ideas. If you look at the roadmap, they are thinking about that, but the team is small. The development is just a couple of years long, so there's a lot to go to.
Anything else?
Is there any company backing the project?
The No Red Ink or something like that. So these are the main companies. The No Red Ink one because Evan, the original author of Elm, and also the Richard Feldman, I think they both are working on No Red Ink. And the company is, of course, using a large production code base of Elm and knows to the support of the open source, and especially their dependency on Elm is crucial for their project. So, but I don't know what they are working or what's their financial status. And also, if you want to know more, the Code Change weekly podcast hosted Evan, I think at least, I don't know, 1 or 2 times, and Richard also, but I don't know who was once and who went twice. And they both are talking about using Elm in production, while Elm is good, how to prototype apps before developing them in Elm, so they are just using some plain jQuery or something like that just to quickly hack together a prototype, get it confirmed, and then rewrite it in Elm. Each of the talks is about 1 hour long, but it really sheds light on how this is done in production, where they have few 100,000 lines of Elm.
Okay.